Have you ever wondered why space is so terrifying yet so captivating? An enigma that stretches beyond our comprehension. The cosmos has always been an object of both fear and fascination for us humans. It's a canvas of the unknown, painted with the most profound mysteries of the universe. This vast expanse of darkness, studded with gleaming stars and swirling galaxies, is a testament to the infinite possibilities that exist beyond our blue planet. But what brings a shiver down our spine is not just its immensity. It's the unknown that lurks in its shadowy corners, the unexplored territories that lie beyond the reach of our most advanced telescopes. It's the silence that echoes in its vastness, a silence so profound that it whispers tales of the unknown. Yet it is this very fear that compels us to explore, to seek, to reach out to the stars and beyond. Now imagine, what if the greatest fear of space is not its vastness but its limitations? Our understanding of space is based on the space-time continuum. This concept, a four-dimensional model combining 3 dimensions of space and 1 of time, is the canvas upon which we paint our comprehension of the cosmos. It's a bit like a vast cosmic fabric, stretching and bending under the influence of mass and energy. Imagine a trampoline and place a bowling ball in the center. The ball sinks, distorting the fabric around it. This is a simplified analogy of how a massive object, like a star or a planet, bends the space-time around it. This bending, this warping of space-time leads to phenomena we find both fascinating and terrifying. The most extreme of these is the black hole, a point where space-time is so severely distorted that nothing, not even light, can escape its gravitational pull. Now, what if there is a limitation in this very foundation of our understanding? The speed of light, the fastest speed we know of, is a glaring limitation in our universe. Imagine this, a cosmic speed limit set at just under 300,000 kilometers per second. As per Einstein's theory of relativity, to reach or exceed this speed would require an infinite amount of energy, an impossibility for any physical object. This limit, known as the speed of light, is a fundamental barrier that affects space travel and exploration. It's like having a sports car with limitless fuel, but an impenetrable wall of traffic ahead. The nearest star to our solar system, Proxima Centauri, is over 4 light-years away. Even if we could travel at the speed of light, which we can't, it would still take us over 4 years to reach it. The enormity of this barrier is staggering. It's a cosmic reminder of our insignificance and fragility in the face of the universe's vast expanse. This limitation, however, is not the scariest one. Time, as we understand it, may hold a terrifying limitation. Our perception of time on Earth, linear and constant, is not the same when we venture into the depths of space. Time is not an independent entity, but rather it is inextricably linked with space, forming the 4-dimensional fabric of the universe known as space-time. According to Einstein's theory of relativity, the passage of time can be influenced by gravity and speed. Near massive objects or at high speeds, time slows down. Imagine venturing into space for a year-long mission, only to return to find decades have passed on Earth. This distortion of time, this inability to sync our clocks with the universe, is a haunting reminder of our human limitations in the face of cosmic forces. Yet, time dilation is not a barrier to be feared, but a mystery to be unraveled. Yet even this limitation is not the most frightening one in space. The very matter that makes up everything we know, including ourselves, has a limitation. As we delve deeper into the cosmos, we encounter an unsettling reality that the very building blocks of life, matter itself, is bound by certain restrictions. The atoms and molecules that form the stars, the planets, and indeed even us, are restricted by a principle known as the Pauli exclusion principle. This principle states that no 2 identical fermions, particles like electrons, protons, and neutrons, can occupy the same quantum state simultaneously. In simpler terms, they can't be in the same place at the same time. This limitation of matter is a fundamental law of nature, governing everything from the structure of atoms to the stability of stars. It's a sobering reminder that even the most basic components of the universe, the very fabric of our existence, are subject to restrictions that we, as mere observers, can only begin to comprehend. But believe it or not, there is a more terrifying limitation in space. What if the scariest limitation in space is our own knowledge? A thought that chills the spine, isn't it? For all our advancements, our understanding of the cosmos remains a mere drop in the ocean. Our knowledge is tethered to our observations to our technology, and our technology to our understanding. It's a cyclical dance of limitations. We gaze at the stars through lenses, both literal and metaphorical, that can only capture so much. There's a universe of phenomena that remain elusive, beyond the grasp of our current technology and comprehension. Dark matter, black holes, the exact nature of the universe's expansion. The mysteries are endless and our knowledge limited. Our understanding of space is like trying to read a book in the dark. We can make out some words, maybe even a sentence or two, but the full story remains hidden in the shadows. This limitation, our own knowledge, is perhaps the most terrifying one in space. Overcoming this limitation is not easy, but it is not impossible. Humanity has always been a species of explorers, pushing the boundaries of knowledge, defying the odds, and reaching beyond what once was thought to be unreachable. From the moment we first looked up at the stars and wondered what lay beyond our own blue sky, we've been on a relentless quest to understand the cosmos. The first astronomers gazing at the heavens with their naked eyes knew not of galaxies or black holes, yet they laid the groundwork for the astronomical knowledge we have today. Fast forward to the 20th century, we ventured beyond our homely planet, stepping foot on the moon, and sent probes to the farthest reaches of our solar system. These were monumental feats of human ingenuity that once seemed impossible. Now we stand at the precipice of a new era where the limitations of speed, time, matter and knowledge are not barriers but challenges to be overcome. With every passing year, advancements in technology and science are pushing us ever closer to breaking these cosmic constraints. Consider the current strides being taken in quantum physics, where particles can be entangled over vast distances, defying our traditional understanding of space and time. Or the development of propulsion technologies that could one day take us to the stars faster than ever before. And let's not forget about the exponential growth of artificial intelligence and machine learning, tools that could unlock mysteries of the universe that are currently beyond our comprehension. These are not mere fantasies, but tangible realities within our grasp. Yes, the challenges are immense. Yes, the path will be fraught with difficulties. But as history has shown us time and time again, humanity thrives when faced with adversity. The journey to overcome this limitation is a long and arduous one, but it is a journey worth taking. For it is in the pursuit of the impossible that we truly discover what we are capable of. And who knows, perhaps one day we'll look back at these limitations as mere stepping stones on our path to understanding the universe. Picture a celestial object so dense, so massive, that nothing can escape its gravitational pull, not even light. A black hole is born from the remnants of a colossal star that has exhausted its nuclear fuel. This star collapses under its own gravity, causing an explosion known as a supernova. What's left is a core so dense that it warps the fabric of space and time around it, creating a black hole. This gravitational monster doesn't just gobble up everything in its path, but it also bends and distorts light, offering us a warped view of the universe behind it. And as you approach its event horizon, that point of no return, time itself begins to slow down. The black hole, a monstrous celestial entity, is a place where the laws of physics as we know them cease to exist. A black hole is not just a point in space, but a region of space-time where gravity is so strong nothing can escape its pull. Imagine it as a cosmic beast, devouring everything that dares to come close. The boundary of this beast, the event horizon, is the point of no return. Cross it and not even light, the fastest thing in the universe, can escape. Inside this event horizon, the fabric of space-time is twisted and warped to the extreme. All paths lead towards the heart of the beast, the singularity. The singularity is an enigma. It's a point in space where the laws of physics as we know them cease to make sense. Here, matter is crushed to infinite density and space-time curves infinitely steeply. The singularity, a point where density becomes infinite, is where our understanding of the universe breaks down. It's a reminder that there are still mysteries out there awaiting our discovery and understanding. Gravity, the force that keeps us grounded, becomes a terrifying power within a black hole. It's a common misconception that gravity is merely the force that prevents us from floating off into space. But in the sinister heart of a black hole, gravity plays a far more menacing role. It's like a cosmic puppeteer pulling at the strings of the universe, distorting the very fabric of space and time. Imagine a sheet of rubber stretched taut. Toss a marble onto it and it will create a dip, a distortion. Now imagine that marble is 1,000,000,000,000 times heavier. That's the kind of impact a black hole has on space, but it doesn't stop there. Gravity within a black hole is so strong it warps time as well. Time, the consistent tick-tock we take for granted, becomes a malleable plaything in the hands of gravity. In a black hole, gravity is so powerful it bends not just space but time itself. Imagine if time could be stretched like a rubber band. This is the reality within a black hole. As we delve deeper into the abyss, the laws of physics as we know them start to wobble, and time itself bends to the will of gravity. This mind-boggling phenomenon is known as time dilation. In the simplest of terms, it's the difference in the elapsed time measured by two observers, due to a velocity difference relative to each other, or due to a difference in gravitational potential between their locations. When you're inside a black hole, you're in the domain of extreme gravity. And gravity, my dear listeners, loves to toy with time. It pulls and tugs at the fabric of space-time, causing it to stretch. This stretching of space-time is what we perceive as time dilation. As you approach the event horizon of a black hole, the boundary beyond which nothing can escape, time stretches out, and for an outside observer, you seem to freeze in time. The event horizon of a black hole is a boundary beyond which there is no return. This chilling statement is not a line from a science fiction novel, but a sobering reality of our universe. The event horizon is the point at which the gravitational pull of a black hole becomes so strong, not even light can escape its clutches. Think of it as the ultimate cosmic one-way street. Imagine you're standing on the edge of a waterfall, the water being time and space relentlessly cascading down into the gaping maw of the black hole. Once you step over the edge, there's no swimming against the current, no clawing your way back up the waterfall. You are inexorably drawn towards the singularity, the point of infinite density at the heart of the black hole. This is the inescapability of a black hole, the reason it is considered a point of no return. It's not just about the strength of the gravity, it's about the warping of space and time. Inside the event horizon, all paths, all directions lead towards the singularity. The fabric of reality itself is twisted so that forward and backward, up and down, inside and outside, all mean the same thing: deeper into the black hole. Yet in this terrifying inevitability, there is a certain elegance, a beauty even. It is a testament to the power and intricacy of the universe we inhabit, a reminder of the grandeur of the cosmos and our place within it. A black hole is not a monster lurking in the shadows, but a natural phenomenon, a part of the celestial ballet that has been unfolding for billions of years. It's a humbling thought, isn't it? For all our achievements, for all our knowledge and understanding, we are still subject to the fundamental laws of the universe. We are still at the mercy of gravity, still powerless before the might of a black hole. Once crossed, the event horizon seals your fate, and escape becomes an impossibility. In the end, the black hole reminds us of the ultimate truth of our existence. We are, all of us, caught in the inescapable dance of space and time. So what lies beyond the event horizon? This remains one of the greatest mysteries of our universe. As we've journeyed through the ominous realms of the universe, we've confronted the anatomy of black holes, felt the unyielding force of gravity, and grappled with the concept of time dilation. These celestial titans are, in essence, the embodiment of space's most terrifying limitation. Black holes are not merely points of interest for the curious and the brave. They are reminders of the awe-inspiring and terrifying nature of our universe. They are testaments to the fact that even within the infinite expanse of space, there exist boundaries, thresholds that once crossed, offer no return. As we venture further into the stars, let us remember this. Let us carry with us not just the thrill of discovery, but a healthy respect for the unknown. While space may seem limitless, the existence of black holes reminds us that even in the cosmos, there are boundaries that should not be crossed.